Situated on the edge of the Canadian prairies sits the capital city of Manitoba, Winnipeg. At the very heart of the city, which 820,000 people call home, is the meeting point of the Assiniboine and mighty Red River. This site has served as an important gathering place for Indigenous peoples since time immemorial, and eventually also for European traders and settlers. It continues to serve as a meeting place today in the form of the vibrant cultural hub of the Forks. The iconic Esplanade Royale currently provides an active transportation link between the Forks and the historically francophone neighborhood of St. Boniface, not only helping to reduce car dependency, but to also connect the scenic river trails on both sides. To improve this connection, the city is conducting a feasibility study into an additional active transportation bridge between St. Boniface and the Forks that can accommodate both park users as well as maintenance vehicles. We are the University of Manitoba Steel Bridge Team. We are made up of over 55 diverse members and situated on the U of M's Fort Garry campus. Before we begin, we would like to acknowledge that the work done by UMSB was on Treaty 1 territory, which is the original lands of the Anishinaabe, Cree, Ojibwe, Dakota, and Dene peoples, and on the national homeland of the Red River Métis. The proposal calls for a 19-foot-long bridge designed to resist 50-pound lateral loads and 2,500-pound vertical loads. The city has requested that steel be used for the design for its versatility and its ability to be easily remanufactured after deconstruction, helping to create a circular economy for the project. The optimal placement for the bridge, however, is also located where an island sandbar has formed in the river. Being home to a variety of wildlife and birds, disruption to the island must be kept to a minimum during construction. Additionally, physical restrictions on site require that the bridge be asymmetrical.
Based on the design requirements and restraints, our team began working to create a 1:10 scale model of the proposed bridge. To begin, we started by splitting our design team into 4 different groups. This not only improved our team's efficiency, but also ensured that everyone was able to express their ideas in the preliminary design phase. This year, we decided to use the structural analysis software SAP 2000, as well as hand calculations to design and analyze each bridge, alongside the Handbook of Steel Construction. Once each team had their frame designed, load cases and combinations were assigned to assess each bridge, allowing us to improve our designs. By using a scoring matrix obtained from the rulebook, we were able to compare the designs, the results of which were used to help choose our final design. The process was then repeated for the bridge connection designs. Our non-symmetrical dual-chord system design features an open-web steel joist top chord comprised of pre-welded ELA members with a CNC'd plate web, as well as a more robust bottom chord comprised of individual pipe members. This satisfies the deflection requirements for the bridge while also minimizing the weight, improving the sustainability of the design. The two-system chord design was also chosen for its effectiveness against resisting load while minimizing deflection. The bridge also features 3 types of connections. Single shear gusset connections were used on the bottom chord, which were chosen to improve constructability, while double shear connections were used on the top and bottom chords to meet strength requirements for the design. Finally, the lateral connections of the bridge are all single shear connections, further minimizing weight and improving sustainability.
Like past years, we partnered with a local company, Abesco Limited, to fabricate our bridge. However, this year our team decided to be more ambitious and to build up our in-house fabrication capabilities. As such, our fabrication team built out our stringers while also making modifications to further optimize the design. To aid in this process, our drafting team created fabrication blueprints as well as detailed 3D models in AutoCAD. This helped to create quality controls during fabrication. By working closely with Abesco's industry experts and combining it with the dynamic talent of our fabrication team, we are able to minimize mistakes, maintain quality controls, and find innovative solutions throughout the entire fabrication process.
From the beginning of the design phase, constructability has been a top consideration. This was achieved by getting input from the construction team at every phase of the project.
This year, we're using 2 barges for both the construction and deconstruction of the bridge. This allows our team to work on both sides of the island, avoiding unnecessary disruption to the natural environment. These barges are then aided by a builder on both sides of the river, making for a total of 4 builders. The construction process begins with the assembly of members to form the primary truss of the north stringer, followed by the primary truss of the south stringer. The vertical components of the undertruss are then attached to the primary trusses, which are then followed by the bottom cords to form the lower arch. Diagonal members are then attached to the lower cord to complete the stringers. Lastly, lateral braces are connected to the stringers to stabilize the bridge. The deconstruction process is almost identical, but in reverse order. This efficient system makes it possible to construct and deconstruct our bridge quickly, which improves the sustainability of the design while also minimizing negative impacts to the natural environment of the Sandbar Island.
The physical performance of a design is not the only thing that matters for a bridge, as its aesthetics should also be considered. Our bridge's geometry and angles take inspiration from the old railroad bridges that crisscross the Red River around the forks. Combining this fact with its deep color palette, this helps our design to blend into the pre-established built environment. At every step of this project, our team worked hard to come up with bold and innovative solutions to countless obstacles. With the support of our industry partners and advisors, as well as our team's diversity, we have been able to bring forward a successful project. With our design focusing on optimized bridge performance and constructability, our bridge offers both an economically and environmentally sustainable option for the proposal. A design that will hopefully serve the city of Winnipeg for generations to come.